Okay, so we're continuing example 2. So I went ahead and, so this is where I left off. And again, we have quadratic factors, a quadratic factor, right, linear and linear factor. And what I did was multiply the LCD, right, which is this guy, to the left and the right hand side, and then I obtained this equation. Now notice these guys, since they're not factorable over the real numbers, we can't just say, s is -3 and get a nice 0 like we did when we had linear factors in example 1. So here and the book, explains this as well in the paragraph, which you're, again, more than welcome to read. But basically what it's saying is when you have an easier route would be, instead of getting these four ugly equations with A, B, C, and D, so you have 3 on the left-hand side. Well, actually here. You have 3 in the numerator, right? And you have this guy in the denominator. And there's no factor of s here. And there's no factor of s here or here. We have, this guy really means, right? This guy really means s squared plus 0s plus 4. And similarly with s squared plus 9. So since this guy, which we love that it's 0s, right? That's not os, that's 0s. When we equate the coefficients, it's just going to work out nicely. So since our s is here and our s is here, right? It's attached with a and c. We can assume, right? We can assume actually that a is equal to 0, which is also equal to c. So because we can say that, then this simplifies this guy, right? This is 3 equals, all right, that's gone. So we get a nice b times s squared plus 9 plus d s squared plus 4. And let's go ahead and just keep simplifying this. So I'm just distributing, right? This guy. So bs squared plus 9b plus ds squared plus 4d. And can we combine like terms? We sure can. We get b plus d, right? Or another way of thinking about it is factoring out that s squared plus our constant terms, right? So there we go. And then again, our equation, right? Here's a constant term. Well, that's definitely equal to this guy. And there's no s squared term here, so that's definitely equal to 0, which is nice. So this implies that 3 equals 9b plus 4d, and 0 equals b plus d. And so again, we get a nice system of linear equations, right, which we've solved before. So I'll just put dot, dot, dot. I know you guys can solve this. B equals 3/5, right? And then after finding B, or if you find D first, then D equals a -3/5. Okay, so let's substitute our B and D back into our expression here, right? This guy, here's our BD, right? And our A and C, remember, were 0. So that's gone and that's gone. So let's see, we have BD, s squared, and 9. Okay, so we have s squared plus 4, right? And then we had our s squared plus 9. And our b, right, was here, so we get 3/5 and -3/5. Okay, so this is our this is our chi of s. Okay, so we want to find, again, the goal is to find x of t, small x of t. Well, I have chi of x, so to get from chi of x to x of t, I'm going to take the Laplace inverse of these guys. Now, again, do we see this expression, right? This exact expression or this exact expression in our table? And I'm just turning again to your table. And I don't see that there. Okay, so that's fine. Let's maybe break it up into maybe something we know. Well, we definitely, we're very familiar with our squares, right? Our sum of squares as well. So I am looking at cosine kt or sine kt. So let's go ahead and maybe just change this up a bit. I'm going to go ahead and pull the 3/5 out. I mean, I'm allowed to do that. Maybe it'll be easier to see. Plus, well, might as well write it's really minus 3/5 times 1 over s squared plus 9. And let's go ahead and, well, we're going to take the Laplace transform of each part. Let's see if I want to do it. Let's actually just keep simplifying this. So, well, this is fully simplified, but I'm looking at this guy and this guy when I want to take this Laplace inverse of this function of s. So 1 over s squared plus 4. Okay, I'm looking again at cosine kt or sine kt. The difference is cosine kt has s in the numerator. Okay, we definitely don't have an s in the numerator, but we can have a constant in the numerator. So again, I'm rewriting. This is 3/5 times, that is a 5, not an s. Okay, this is s squared plus 4, right? Which is, again, really, again, if you want to write 2 squared, that's fine. If 2 was up here, right, because this is our k, then this guy, right, this whole thing, I mean, we can use a sine of kt, but there is no 2 there. But again, we can make a 2 appear there, right, by well, so if I put a 2 up there, I'm really multiplying by 2. So I can probably divide by 2, right? Because I didn't change the value of this expression, right? I just multiplied by 1. Okay, so I'm going to go ahead and leave that there. Similarly, 3/5, and again, I have s squared plus 9, right, or 3 squared. So it'd be nice if I have a 3 up here. Well, can definitely do that by multiplying by a third, right? Because again, I'm really multiplying by 1. A third of 3 is 1. Okay, so now I want to take the Laplace inverse. So I'm going to go ahead and, I know it's going to be x of t. I'm going to take out, well, these are my constants, so it's really 3/10. And so I'm going to take the Laplace inverse of this guy, s squared plus 2 squared. And then again, multiply these guys, well, which is really a fifth, times the Laplace inverse of this function of s. And hopefully, you can see that, right, this guy right here, let's maybe put some color. Let's do, oh, I don't know, blue looks nice. Okay, so blue, right, this guy, the Laplace inverse, the inverse transform of that function is definitely sine kt. So this is sine 2t, right? It's got to be a function of t minus 1/5 sine of 3t. So there is our function of t, and let's see if that's, I'm hoping that's correct. Hopefully I don't have any mistakes. And 4.2, and sorry, I'm just flipping here. I like to reference things. Sine 2t, yep, that's it. So that is our x of t. Definitely a trigonometric function. Right, this is really a position function, right? If you read in the book, right, this is a mass and spring system satisfying these the initial conditions that we have. Okay, so that is example 2. Hopefully that clears a couple things. Maybe there, I know there's a couple of gaps in the book. If you have any questions, again, you're more than welcome to ask me. If you'd like me to do a couple more problems, I'd be more than happy to. Just let me know which ones you'd like to see. And I think that's it.